Um, and just so you know, I will not be going over the recipes for these cells and integrated circuits because all the recipes are easily available on Eloraam's website. Now this torch, it's sending a signal through the magenta wire, so let's go see where the magenta wire is connected to. It's going through this bundles cable and it connects right here. This device, which may look a little menacing, a little less menacing than those two, or those two, it's actually pretty simple. The cells here, there are null cells and non-invert cells. So when when there is no signal being passed through these non-invert cells, they all appear to be off. But let's look here. Through the magenta wire, there is a signal being passed through these two non-invert cells. So these two columns of wires are activated, whereas these two null cells do not pass a signal to the top like the non-invert cells or the invert cells might. So now, only the blue cable and the magenta cable here, separate from this, are receiving signal. And that signal gets passed to this, but I will explain that later. Basically, in this circuit, the null cells act as zeros and the non-invert cells act as ones. Right now, it's 0, 0, 1, 1. Basically, how binary coded decimal works is it's a 4-digit number, whether it be a single digit number or 2-digit. This only goes up to 9, so it never reaches a 2-digit number. Right here, this is 0. It's all zeros, so it registers as 0 on the display. And basically, the next one is 3 zeros and a 1. That registers as 1. But it's a little different about how it counts upward after that. This one, it's 2 zeros, 1, 0. The non-invert cell is a 1. And that indicates that it's a 2. This one has another non-invert cell after it. So it's 0, 0, 1, 1. And that means it's 3. And as it gets to the next number, the invert cell moves over one more, leaving 2 zeros behind it. And that's basically how it increments. I'll go up here a little further. Let's see, this is 3 here, and that's 4, that's 5, that's 6. No, that's not 6. That's 7. Sorry about that. It's a little hard to keep track on this thing. So this is 1 0 and 3 1s. Basically, as you can see here, it increments the same way as what it did for the 3. Once it gets to 4, it moves over 1. But the zeros behind it all have to become 1s before the next number can increase. See, this has 3 zeros. Once it gets to the number afterwards, the non-invert cell moves over. And then it starts to fill up again with more non-invert cells. That's how binary coded decimal works, in a nutshell. So let's see. I'll go back over here. Basically, what the invert cells do is when you have a row of the non-invert cells, the top wire is always active. But once you pass a signal to, actually, I'm sorry, when you are not passing a signal to a non-invert cell, the top wire that goes over across the non-invert cell is active. But if you have a invert cell, the wire above it becomes it deactivates when you pass the signal through it. So that's why this has turned off. So let's go over here. I'm gonna increase once more. I'll set it to 4. So as you can see, there are now 4 counters sending a signal. The output, the output has moved down one more line. So there's 4 invert cells. It sends a signal through the green wire, and over here, the green wire sends a signal to this one. It's 0, 1, 0, 0. And then that sends a signal to this orange wire. It's like a dark orange. And now, since I basically told you how that works, I'll go over here and explain this. This converts the binary coded decimal into a signal that can be understood by this circuit. This one here, it basically has a pattern to match the input from those wires there. Right now it's just the orange wire that is active, so this orange wire goes up through here, and the pattern is 2 non-invert cells, an invert cell, and another non-invert cell. So it's basically 0, 0, 1, 0. It translates it. Actually, no, that's not quite right. It's a little bit backwards. I'd have to be facing it this way. It's 0, 1, 0, 0. I don't know why it's set up like that, but that's basically how I copied it. That basically, whenever the input or the pattern over there matches a pattern on this board, it turns off whatever wire matches it. It's just a bunch of series of non-invert cells and invert cells, but it always matches one of the outputs from that circuit. So let's see, right now it's at 4. This one registers as 4. The signal, because it's off, it has to be inverted to send a signal through this torch. The torch activates this row, and this circuit corresponds with how or what number appears on this here. Right now it's set at 4. So let's take a look. This torch activates this row right here, which activates 2 wire columns, and it's a series of null cells and non-invert cells. So whenever it's not receiving input, the non-invert cells are basically off. Well, yeah, they should be off. So let's see. This has a null cell, 2 non-invert cells, 2 more null cells, and 2 more non-inverts. The only wires that are active are the ones with non-invert cells under them. So let's take a look. These 2 wires, white and orange, are active, and yellow and green. So let's take a look at where those wires go through this bundled cable. The green wire goes up here. It activates the middle line for whatever number is activated. If it's at 0, it would be deactivated. As you can see here, this one would activate 0. It has all non-invert cells and 1 null cell. The null cell would be the only one that's not active as the signal passes from this torch to this row. So all the rest of the light block